To name organic compounds, we need special set of rules, and the system adopted to name organic compounds is IUPAC system. IUPAC stands for International Union of Pure and Applied Chemistry. To make it further more simpler, we divide naming in two categories. First, for the compounds, hydrocarbons. Hydrocarbons are organic molecules that just have hydrogen and carbon as atoms in them, and the general formula for them is CXHY. And all other organic molecules comes under the category functional group. That is, they have atoms other than a carbon and hydrogen also present in them. And to make our study further more simpler, we divide hydrocarbons also in three categories, namely alkanes, alkenes, and alkynes. So, alkanes are all the hydrocarbons that just have carbon-carbon single bond present in them. Alkenes are all the hydrocarbons having one double bond in them. Like even one double bond is present in a hydrocarbon, it is named as alkene. Similar is the case with alkynes. If even one triple bond is present in the hydrocarbon, it is named as alkyne. Let's start with nomenclature of alkane first. So there are a few important points that you should know about alkanes before learning their naming. The first important point is that general formula for alkane is CnH2n plus 2. That is, for any alkane having n carbon atoms, it's always true that number of hydrogen atoms will be 2n plus 2. Second important point about alkanes is that all the carbon atoms in alkanes are sp3 hybridized. All the carbon atoms, and this is very important to remember. And alkanes are also known as paraffins and saturated hydrocarbons. Okay, let's start with the rules now. So, the rule number 1 to name alkanes is select the longest chain. So what I mean to say by longest chain is select the chain having maximum carbon atoms in it. This is the most fundamental rule to name alkanes. So let's check out this with one example. So in this example, it should be clear that the longest chain is this, which is having 1, 2, 3, 4, 5, 6, 7 and 8 carbon atoms in it. Let's solve few examples and select the longest chain. So I'm starting from this corner. Be careful over here. As a joint comes, so the trick is be careful at the joint. So select the path which you find which is the more long. So I go to this path and here is again a joint, so be careful and then turn this side, and yeah, here is your longest chain. So you need to just keep 2 points in your mind, that first from where you should start. So start from a point where you can see a longer subchain, and second point that you need to be careful at, that whenever you come to a joint, be very careful that which way you need to turn. So in this question, I find this corner as the most suitable corner from where I should start, because I can see this part as the longest chain, like before the joint. So I start from this corner. So here I go, and here is a joint, so I need to be careful. Turning at this side will give me more carbon. So at this joint, both sides are identical, so I can turn to any side. So the highlighted one is my main chain. So let's go to the question number 3. So in this question also, now we should see, like, we should start from this end or this end. So what you can do is you can always count the number of carbon atoms. So here if I start from this corner, it's 1, 2, 3, 4, and this is the 5th carbon. And if I start from here, it's 1, 2, 3, 4, and 5 and 6. So not from here, I should start from here. So again, I'll just repeat those 2 points. You should have them crystal clear in your mind. So I'll start from this corner. Here is a joint and I need to be careful. So I can see that at this side, if I go, there are more number of carbon atoms. So I'll turn to this side. And again a joint, so I need to go here. It's very clear. Then here and then here. You can always just calculate, like, number of carbon atoms this side are 1, 2, 3, 4 and 5. So this was the joint which was of concern. So if I turn the way I turned, there are 5 carbon atoms, and if I would have turned this way, there were 4 carbon atoms. So obviously this direction is the correct direction where I turned. So hence this is our main chain. So let's solve the another example. So in this question, I'm starting from here because it's very clear that I should start from here only. Yeah, so here is a joint. So yes, obvious, it's very obvious I should turn this way. Here is a joint, again be careful, turn this way. Again a joint, turn this way. So that's our main chain. Look this example very carefully. In this example, there are 2 possible longest chains. So the first longest possible chain is this, and the other longest possible chain is this. In both of these chains, the maximum number of carbon atoms present is 7. So the doubt comes is, then which of the chain is correct? Because obviously if we are talking about nomenclature, there cannot be 2 longest chain, or there cannot be 2 ways to name a single compound. A compound should have a unique name. So here we need to describe our rule number 2, and our rule number 2 comes in the action. So what rule 2 says is, if there are 2 or more than 2 longest chains present, then select the chain having more number of branches. Branches is subchain. Okay, so in our example 1, we can see that the first longest chain is having 1 subchain, that is this chain. And in our example 2, we can say we can see that there are 2 subchains present. So one is this ethyl subchain and one methyl subchain. So obviously this is our correct longest chain, and this is the correct longest chain for this molecule. Let's solve few questions and select the correct longest chain. So in the example number 1, I can start from here or I can start from here. So in reference to this particular joint, if I start from this carbon atom, I get 1 extra subchain, and if I start from this carbon, I'll get 0 subchain. So according to the rule, I should select the longest chain having more number of subchains. So ideally I should start from here. Okay, so here comes a joint where I should be a little careful. So if I turn this way, I'll get a subchain, and if I turn here, I'll get 0 subchains. So obviously I should turn this way, this side, according to the rule. So this is my correct longest chain. Okay, so let's come to the question number 2. So again, I can start from here or start from here. To get more number of subchains, I should start from the above corner. Okay, so here comes a joint. I can see that both the sides there are same number of carbon atoms, 1, 2 and 3, 1, 2 and 3. So if I go this side, I'll get 2 extra subchains, and if I go this side, I'll get 0 extra subchains. So I should turn this way. So while solving questions, you should also keep this thing very clearly in mind, because to name a compound, it's very important to recognize the longest chain, because that's your main chain. So if you recognize the longest chain which is not correct one, so obviously you'll end up to the wrong answer. Okay, so if I see this problem, I should turn this side to get more number of subchains. Yeah, and this is my longest subchain. Okay, once we have selected our correct longest chain, the next thing that we do is numbering of the main chain. Okay, so let's check the numbering through one example. So, in our first example, it's very clear that this is our correct longest chain. And in this example, numbering can be done in two possible ways. One is starting from the leftmost corner, first, second, third, fourth, fifth, and sixth. And the other way is starting from the rightmost, first, second, third, fourth, fifth, sixth. So now, which of this numbering is correct? So, to define this, IUPAC states another rule, rule number 3, which says numbering of main chain is done such that the first substituent is the subchain, receives the lowest locant possible. Okay, so the locant of a substituent is the number of carbon at which it's lying. So if I talk about this substituent, its locant is number 3 because it lies on the carbon number 3. And in this example, if I talk about this substituent locant, its locant is 4 because it lies in the 4th number of carbon. So what the rule says is that we need to select. See this example. Let's select the longest chain. So this is the longest chain. Now the next step is to number the chain. Numbering can be done in two possible ways. First, starting from the leftmost corner, and the other way is to start from the rightmost corner. Okay, so now according to the rule 3, we need to select the numbering in which our first substituent gets the lowest locant. So in both of these numbering, the first substituent is getting locant number 2. So now, which is the correct one? For this, rule number 4 needs to be considered. Rule number 4 is also known as the sum rule, which says if first substituent gets same locant, then select the numbering in which the sum of the locant is minimum. Okay, so in our first numbering, the sum of the locants is 2, 4 and 5. So 2 plus 4 plus 5, that is 11. And in the next possible case, locants are 2, 3 and 5. So sum is 2 plus 3 plus 5, that is 10. So yes, it's very clear that 10 is less than 11, so the correct numbering is this. And hence, we select this as the correct numbering. Let's solve these two examples on numbering and make our concepts more clear. So before numbering the chain, let's select the main chain first. So in our example number 1, the main chain is this. So I start the numbering 1, 2, 3, 4, 5, 6 and 7. And the other way I can name this chain is 1, 2, 3, 4, 5, 6 and 7. So, what our rule number 1 about numbering says is that first substituent should get the minimum locant. So, in the white color numbering, the first substituent is getting 2 as the locant, and in the green color numbering, the first substituent is getting 3 as the minimum locant. So, obviously the numbering with white color is correct and the numbering with green color is wrong. So, the correct numbering of the chain is this. Okay, let's solve the second example now and select the main chain first. So, this is my correct main chain and I'll do the numbering 1, 6. The other numbering possible is 1, 2, 3, 4, 5, 6 and 7. So if I check about the first substituent first. So in the white color numbering, the first substituent is getting 2 as locant, and even in the green color numbering, also the first substituent is getting 2 as the locant. So we'll go to the sum rule in this case. So if I check about the white color numbering, the locants that I'm getting is 2, 4, 5 and 6. 2, 4, 5 and 6. And if I check the green color numbering, the locants that I'm getting is 2, 3, 4 and 6. So I can see that I'm getting, if I check the sum of both of these, this sum is 17 and this sum is 15. So this sum is less than the above sum, hence in this case the green color numbering is correct and white color numbering is wrong. So the correct numbering will be starting from the rightmost corner, and this is the correct numbering. Look this another example carefully. To number this compound, we need to select the main chain first. This is our main chain. And again, numbering can be done in two possible ways. 1, 2, 3, 4, 5, 6 and 7, or the other way. So, in the first numbering, the first substituent is coming at the third locant and the second substituent is coming at the fifth locant. And in the other numbering, the first substituent is also coming at the third locant and the second substituent is coming at the fifth locant. So, in this case, the rule number 3 and rule number 4 both cannot give us the correct numbering because the first substituent are in both the cases the first substituent is giving us the same locant, and the sum rule for both is also same, as the locants are 3, 5, and in this case also the locants are 3 and 5. So now what should we do to select the correct numbering? So here comes our rule number 5 when these situations arise. So what rule number 5 states is that if first substituent have same locant and if sum of all locants is also same, then we select the numbering in which alphabetically lower substituent gets lower locant. So in this example, this is methyl substituent meth and this is ethyl substituent eth. So in this case, ethyl is lower alphabetically than methyl, as E comes before then M alphabetically. So ethyl is the lower substituent. Hence, according to the rule, ethyl should get lower locant than methyl. So in the second numbering, ethyl gets 3 as locant, and in the first numbering, ethyl gets 5 as the locant. So hence, our second numbering is correct and this numbering is wrong. So always remember that when you are doing numbering of your main chain, that first thing that you need to see is the lowest locant. After that, you need to see the sum of all the locants, and if that also doesn't work out, then the next thing that you need to see is the alphabetic order of your locants. So while solving all your questions, just remember this order and check and number your chain accordingly. So once you've selected your correct main chain and also numbered it, then comes this general formula to name it. So this general formula is not only for alkanes but for any organic molecule present around us. It has 4 different parts: prefix, word root, primary suffix and secondary suffix. We will discuss each of this part in detail. So the first one is that we will discuss is word root. So what exactly word root is? Number of carbon atoms in your main chain. So once you have selected your main chain, obviously you can count the number of carbon atoms in it. So for specific number of carbon atoms, there is a specific word root that we need to memorize. So I'll just draw a rough table that you need to memorize and word root for it. Okay. So if number of carbon atoms is 1, the word root is meth. If number of carbon atoms is 2, the word root is eth. If number of carbon atoms is 3, the word root is prop. You need to memorize all of these words. It's very important to name your organic molecules. If number of atoms is 4, the word root is bute. If it's 5, it's pent. If it's 6, it's hex. If it's 7, it's hep. If it's 8, it's oct. For 9, it's non. For 10, it's dec. For 11, it's undec. For 12, it's dodec. For 13, it's tridec. I'll continue this table down over here. So if it's, I'll draw a line. So if it's 14, it's tetradec. If it's 15, it's pentadec. If it's 16, it's hexadec. If it's 17, it's heptadec. Octadec. For 19th, nonadec. And for 20, ecos. Once we have found the correct word root for our general formula, next we try to find out is primary suffix. So what exactly primary suffix means is, if there are only single bonds present between carbon-carbon atoms, the suffix we use is ane. That is, it's an alkane derivative. Or if there is even one double bond present between two carbon atoms in our entire molecule, the suffix that we use is -ene. And if even there is one triple bond present between two carbon atoms in the entire molecule, the primary suffix that we use is -ine. So now after deciding our primary suffix, next we decide is the secondary suffix. So what exactly secondary suffix depicts is functional groups. So they are not for so importance now because we are discussing nomenclature of hydrocarbons which do not involve any type of functional group. So secondary suffix is not so important for now. Yes, but when we will discuss the nomenclature of functional groups, we will surely discuss secondary suffix in detail. So the fourth segment of general formula is prefix or prefixes. So to understand prefix better, let's take an example. So in this example, our main chain is this, and to number it, the correct numbering is this. So we can find the word root of this as there are just 4 carbon atoms, no functional group, so no secondary suffix, and primary suffix is -ane because there are only carbon-carbon single bond present throughout. So what about this now? And here comes the importance of your prefixes. So what exactly prefix is? They represent side chains. Now I'm particularly talking about alkanes that we were discussing. So prefix represents side chains. So if I talk about this side chain, it is having one carbon atom, or in general for any alkane having side chains, the general formula for the side chain will be CnH2n plus 1 type, because we remove one hydrogen and attach the main chain with this alkane group. So what we call this CnH2n plus 1 is alkyl. So for different number of carbon atoms, we have different names for these alkyls. So here's a chart. So when one carbon atom is there, the word root we know for one carbon atom is meth. So it will be methyl. For two carbon atoms, the word root is eth. So when we are talking about alkyl, we'll just add yl to it. So the new alkyl is ethyl. For 3, it is propyl. For 4th, it is butyl. For 5, it is pentyl, and so on. So what our prefix represents in alkane is the side chains. So it's very important to remember this. We analyzed the 4 different parts of the general formula and how to select the main chain and everything. Now let's go through one example and exactly check out how naming of a compound is done. So our first example is this. Okay, so let's go according to the rules as we discussed. So first we need to select our main chain. By knowing a fact in the brain that we need to have the maximum carbon atoms in our main chain, and after selecting our main chain, the next important part that we need to do is number our chain. So in this case, we will number our chain in this way by keeping those points in mind that first locant should be the lowest number, and some of the rules in alphabetical order, and this is the correct numbering. So now let's go to the general formula, and what ideally you should always do is first find the word root. So in this question there are 6 carbon atoms present, so the word root will be hex, and the suffix will be -ane, primary suffix, because there are no double and triple bonds present, and there will be no secondary suffix as there is no functional group. And now let's check our prefix. So for prefix, we are just forgetting this part. So as we discussed earlier, that this is an alkyl group, and this is an alkyl group having one carbon atom. So the prefix will be methyl, and as it is present at second position, so we'll name it like 2 hyphen and a methyl. So and what will be the final name? So before getting to the final name, you should know very important 3 rules. So the rule number 1 is the gap between a number and a number is filled with a comma always. It's very important, this comma, always remember. Second, the gap between a number and a word is filled with hyphen. Again, very important. So you can see in 2-methyl, between 2 and methyl, I put a hyphen over here. So please remember that. Third important point is that the gap between a word and a word is filled with 0 space. So that is, you'll attach 2 words, there will be no gap between them. So it's important, please remember these 3 points. Now let's name a compound after learning these 3 rules. So the compound name should be 2-methyl, no gap between methyl and hex, and no gap between hex and ane. So the name of the compound is 2-methylhexane. So in example number 4, the correct main chain is this, and numbering can again be done in 2 possible ways, but the correct numbering is this. So in our main chain there are 7 carbon atoms present. So the word root is hep and primary suffix is ane, as there are no double and triple bonds present. So now only prefix is remaining. So on second and third positions there are methyl groups attached. So there is a specific way to write it. So let's see it carefully. It's represented like 2, 3 dimethyl heptane. So just carefully see that 2 numbers are separated with a comma, and a number and a word is separated with a hyphen, and there are no gaps between any word. So this is very important. So if there are 2 identical, 2 or more than 2 identical substituents present, so we use the word di, tri, tetra accordingly. Okay, now let's see the next example. Example number 5. The correct main chain is this. Numbering can be done in either way, as the molecule is symmetrical. So the word root is hept, as there are 7 carbon atoms present in main chain. So let's see about the prefix. On third, fourth and fifth position, there are methyl groups present at substituents. So we will write it in this way: 3, 4, 5 trimethyl heptane. This is the correct name of the compound. So now see example number 6. So the correct main chain is this. Numbering can be done again in 2 possible ways, but the correct numbering is this. Word root is hep, primary suffix ane. There are 2 substituents at third and the fourth position. So now the things comes in concern is that which should be written first. So the rule that follows over here is also the alphabetical rule. So the word which comes alphabetically before will be written before. So as eth comes before meth, so eth will be written first. So it's 3-ethyl 4-methyl. Be very careful that between a number and a word there is a hyphen. Same I've done over here, same here, and no gap between 2 words. So it's very important to remember this, and also remember that ethyl has been written first before methyl. just because E comes before M in dictionary order. Let's solve few examples on nomenclature of alkanes step by step. So the first step is to find the longest chain. So in the example 1, the longest chain is this. Next step is to number it. So remember the rules in the mind. The lowest locant rule, sum rule and alphabetical rule. So this is the correct naming. Now next step is to jump to the general formula and find the word root, etc. So the word root, since there are 6 carbon atoms, so the word root will be hex, and since there are no double and triple bonds, so hexane. No secondary suffix required as there are no functional groups, and only this alkyl group is present at third position. So, and it's having 1 carbon atom, so it's methyl. 3-methyl hexane is the correct answer. Okay, let's check the second example. So the correct main chain is this. Let's number it. We can number it from either side, it won't make any difference. The compound is symmetrical. So the word root is hep. Ane is the primary suffix as there are no double and triple bonds. And on 4th carbon, there is an alkyl group having 2 carbon atoms. So the word root for 2 carbon atoms is eth, and it's an alkyl group, so we'll name it as ethyl. So 4-ethyl heptane. No space between ethyl and heptane, that's really important. Solving the third example, the correct longest chain is this. The correct numbering is this. Okay. So as we see, there are 8 carbon atoms, so the word root is oct. No double and triple bonds, so octane. And on 4th position, there is a 2 carbon alkyl group present, so ethyl, and it will be 4-ethyl octane. We have solved a variety of questions on nomenclature of alkanes, but in all those examples, the substituents that we considered were simple, such as CH3-methyl. Okay, so when I'm drawing this line, you need to consider it as like this line is connecting the substituent with the main chain. So just imagine there is a main chain over here and this is your substituent. Next simple substituent that we considered was ethyl propyl. Okay, now I'll give you an example of a complex substituent and then we'll see how do we name complex substituents in our general formula. So there are specific rules to name these prefixes. So how do you do this is, we will just go to the initial methods that how we started nomenclature of alkanes. So in such complex substituents, the first thing that you need to do is to select your main chain. So the main chain will be the chain that will be starting from this carbon which is just attached to your main chain and having maximum carbon atoms in it, and follow the other same rules as we did. And next rule that comes into picture is numbering. So you need to do the numbering of the complex substituent chain just as we did in nomenclature of alkanes, but here you need to keep one thing in the mind, that number 1 will start from this carbon atom only. Okay, so this is 1, this is 2. So how will you name this? Again, you'll just apply a general formula that your word root is eth over here because you are having just 2 carbon atoms, but here you won't use the word ethyl. Here you won't use the word ethane, you will use the word ethyl only. So the general formula that you will write over here is 1 methyl, because in the first position you are having a carbon atom. So 1 methyl ethyl. This is the correct name for this complex substituent. Let's see other examples as well. So how will you name this complex substituent? The first thing that you need to do is select your main chain, do the numbering 1, 2, 3, and then just name it. So you can see that on second position there is a methyl substituent. So 2-methyl propyl. Yes, and just remember that these complex substituents are always kept in brackets. Like they are not named like a simple nomenclature of alkanes, like we used to attach this propyl with your, if there is an hexane or there is an heptane, but in these cases we keep them in a bracket. For complex substituents, if there are 2 or more than 2 identical substituents present, we do not use di, tri or tetra over here. Instead we use a different chart. Let's see. So the chart that we use over here is, for 2 we use the word bis, for 3 we use tris, for 4 we use tetrakis, for 5 we use pentakis, for 6 we use hexakis, and so on. Let's solve these few examples on nomenclature of alkanes having complex substituents. So the first step is always to select the main chain. So this is our main chain having maximum carbon atoms. Next step is to number this chain, and according to the rules, numbering should start from here in order to get the lowest locant for the first substituent. So our word root will be hep and primary suffix will be ane. Now let's check out for the prefix. So this is a simple substituent, that is methyl substituent, but this is a complex one. So here also the rules are absolutely same. First we need to make its main chain, then do the numbering. So 1 and 2. So how I'll name this complex substituent is 1 methyl ethyl, and in round brackets. So this is a ethyl substituent and this is a methyl substituent. So while naming the compound as a whole, ethyl will be named first, then methyl, because ethyl comes first alphabetically, then methyl. So let's finally name our compound. So the correct name for this compound will be 4,1-methyl ethyl, again a hyphen, 3-methyl heptane. So this is the correct name for the compound. Okay, now let's solve our second example. So again the first step will be to select the correct main chain. So in this example the correct main chain is this. You can number it either way as the compound is symmetrical. Okay, so these two substituents are identical. These two substituents are identical. So let's name them. So the name for this substituent is 1-methyl ethyl. So the correct name for the compound now is 4,5-bis. As we discussed before that we don't use di, tri and tetra over here. Instead we use bis, tris and tetrakis. So 4,5-bis hyphen 1-methyl, ethyl, round bracket closed, octane. So the important rules to be remembered is that between two numbers there is a comma, between a number and a word there is a hyphen, as you can see over here also and here also, and between a name and a name there is no gap. So please do remember these points, they are very important, and these are the names for these complex substituent alkanes.